All right, so for example 3, it says a physician claims that joggers' maximal volume oxygen uptake is greater than the average of all adults. A random sample of 15 joggers has a mean of 40.6 milliliters per kilogram and a standard deviation of 6 milliliters per kilogram. If the average of all adults is 36.7 milliliters per kilogram, is there enough evidence to support the physician's claim at 0.05? Assume the variable is normally distributed. So we're going to go through our state plan do conclude list, even if we're not writing it down formally. So first thing I need to do is figure out what it's asking me to do. And we know it's a significance test because we're in the significance test unit. Good. So question is, where is the wording in the question that tells me that? Raise your hand if you see it. Let's stop. Very good. Is there enough evidence? Amanda, did you see anything else that tells us that? No, that was, you were seeing the same thing? Good. They also say claim. We're testing a claim. They give us a significance level. Yeah, very good. So I know I'm doing a test. And then the question is, what am I doing a test for? Is this a mean or a proportion? And I see the keyword average. So it's definitely a test for a mean. So I'm going to write test for mean. I need to decide at this stage whether it's a t-test or a z-test. And to do that, I scan the problem for standard deviation. And the question I'm asking myself is it a population value or a sample value? So when I scan through here, I see random sample of 15 joggers has, and then they give me a mean for that sample, and they give me a standard deviation for that sample. Both of those values come after the 15 joggers have. It's in the same sentence with the sample data, so they have given me a sample standard deviation. This value here is an SX. This is an X bar. If I have SX, which type of test am I doing, Z or T? Ooh. Brownie face. Z if I have a population value, T if I have a sample value. If I have a sigma, it's Z. If I don't have a sigma, it's T. That is important. If it's population standard deviation, so if I have sigma, I'm performing a z-test. No sigma, I'm performing a t-test. And remember, sigma stands for population standard deviation. Population value, population SD. Nowhere in that problem do they mention the phrase population standard deviation. The only time I see the phrase standard deviation, it's attached to a sample. So I have an SX, not a sigma. That's important. Okay, so they gave us sample values. They gave us one more thing, which is they gave us this here, the average for all adults. That's our population claim, all adults. So that's the number that's going to show up in our hypotheses. There is a keyword that tells me about my alternative and the symbol that goes in my alternative. Where is that keyword? Greater than, yeah, good. So physician claims the joggers are greater than all adults, the average for all adults. Good. So let's go ahead and write our hypotheses. We'll go through our checks. We'll do our test. So HO, HA. It's a claim about a mean. My null is always a statement of equality. I know my number for the population is 36.7 milliliters per kilogram. 6767. I know. guys can't help yourselves. And we know is greater than. So here it is greater than. If you struggle with greater than and less than in terms of direction, slap that on a flashcard, add it to your flashcard deck. Yeah, we have to be able to tell the difference. Yeah, remember we read sentences left to right. Less than, you see the tiny end first. Greater than, you see the big end first. That's how I remember. Good. So checks. We'll go through a list of 3 things. First thing we're checking for is random. Are we told random? Yes. Very good. They said a random sample. So check 1. What else do I need to check? Independence. Very good. So we look at our sample size, which is what? 15 joggers. Is 15 joggers less than all adults? Yes. Clear that bar nicely. Last check. What am I doing for my last check? Who remembers? Normal. Very good. And I go through a list of 3 things. Is my sample bigger than 30? No. Am I told the population is normal? Yes. Yes, that last little sentence, assume the variable is normally distributed. They're telling me that that oxygen intake for the population is normally distributed. That's not common, but sometimes we are told that. So we pass the normal check. So we go to the calculation. I am going to calculate 2 numbers. 2 numbers. Prarthana, what 2 things do I need to calculate for my test? Z or T score, so I need my test statistic, and what else? Those are underlined. What does that test statistic then give us on our calculator? P-value. P-value. Yeah, I need a test statistic, p-value. Test statistic we're going to write a formula for. P-value is then going to come from our calculator. Yeah. Test statistic is that big ugly fraction. Doesn't need to be that long. And on the equation sheet, it is sample statistic minus population parameter divided by standard error for your statistic. So we need the standard error formula for the mean, which is standard deviation over square root of n. And in this case, we have an Sx. So Sx over square root of n. If I had a sigma, I'd use a sigma instead. Yeah, I sympathize. We plug and chug our values. So X bar for our sample of joggers was 40.6. The population claim for all adults was 36.7. The standard deviation for our sample was 6, and we had a sample of 15 joggers. So on my calculator, where am I going? Oh no. Mel, on my calculator, where am I going? T-test. Very good. T-test. Stats, test, T-test. In this case, we have statistics, so you should enter stats, because we didn't put any data in a list. My calculator is spitting out 2.517 rounded and 0.0123 rounded. Can I get a thumbs up if your calculator gave you the same thing? I see thumbs up popping up around the room. You should be following along on your calculator, yes. And then we make our decision, we write a conclusion. We're not going to write the sentence. We should at least write our conclusion, our decision down. And we go to our trusty phrase, if the p-value is low, reject HO. Is that lower than alpha? Yes, our p-value is less than our alpha, so we are going to reject our null. So yes, reject means yes, we have evidence. So in this case, the answer would be because our p-value of 0.0123 is less than alpha 0.05, we reject the null. There is convincing evidence to support the physician's claim that joggers' maximal volume of oxygen intake is greater than the average for all adults. Most of the words that just came out of my mouth came from the word problem. Reminders that you should not be inventing new sentences. Pull wording from the question. Right? This is not English class. You do not have to get creative with your writing. Sentence frames and pull words from the question. You know that went on record last time, right? All my periods know about it now. Yes, really. All right, questions on example 3 before we move on to what we do with paired data. No, everybody looks wide awake on Monday morning. Okay. So, the upside, tests for mean differences work exactly the same as tests for a single list of data. Just like for confidence intervals, the data has to be paired if I want to run it as a single test, meaning that those two data values that I am finding a difference for had to come from the same person or two identical people. And I'm generally looking at experiment data, not observational data. I gave somebody a placebo and then a treatment. I'm measuring their heart rate before and after a jog. The two data points are coming from the same person, they're tied together. When we're doing this, we are always performing a t-test, just like with confidence intervals and t-intervals. So on your calculator, you're using the t-test command. We don't have to think about it for paired data. If I'm looking at a mean difference, it's always t. We're going to do one short example, just like example 3, where we're only doing bits and pieces, and then we're going to do the full state plan do conclude. Yeah? Okay, so do I have a volunteer who wants to read example 4 for us? Thank you, Hilani. Perfect. Thank you, Hilani. So we go through our list. Before we tackle the state plan do conclude, what are we being asked to do? Find convincing evidence. Very good. Do these data provide convincing evidence? Which screams hypothesis test. And it mentions caffeine withdrawal increases depression scores on average. So I'm probably doing a test for a mean. And in this case, I can clearly see that it's not just any mean, it's a mean difference. This is a test for a mean difference. Anytime it's a mean difference, it's a t-test. So t-test for mean difference. And if we were doing the state plan do conclude, we would define it. The mean difference between depression scores for placebo minus caffeine. So we pick through, they didn't give us a whole lot of data in the problem, but they gave us a list. I'm not actually interested in caffeine or placebo. I am interested in the difference. So take a minute, fill this row out. Double check that I can subtract correctly. Pretty sure I did that correctly. I know my sample size is 11. They told me in the problem. 11 subjects. I'm going to get my sample mean and my sample standard deviation from that list. That's going to come when I run my t-test, so I don't have to worry about finding those now. There is one other number that I need to run a significance test. What did they not give me that I desperately need in order to perform a test? Alpha. Yeah, they didn't give me an alpha. I don't know what my significance level is, so I have to pick one as a researcher. You can't mess this up on the test as long as you write it down, whatever you used. The default is generally 0.05, but if you ran it at 0.01 or 0.1, you'd be fine, as long as you wrote it down. Write it down. I need to write my hypotheses so I know what I'm testing. So HOHA. I know these are claims about mean differences, so mu D, mu D. I know my null is always a statement of equality. And I have encountered another problem. Let me scroll back up. In that word problem anywhere, do you see a stated value for the population mean difference? Increase tells me about my alternative, but population mean difference, did they mention a value for that anywhere? The answer is no, nowhere in there. So what we are assuming is there's no difference between caffeine and placebo. And we are testing if caffeine withdrawal increases depression scores. And for this, we have to think carefully. We did our subtraction, our difference, as placebo minus caffeine. Placebo is caffeine withdrawal, no caffeine. And we're saying caffeine withdrawal increases depression scores. So if I subtract placebo minus caffeine, I am subtracting presumably higher depression scores minus lower depression scores. Will my answer be positive or negative? Positive. Higher minus lower is positive. So these should be, if the researcher is correct, bigger than 0. Caffeine withdrawal causes depression scores to go up, causes that mean difference to be positive. Before we run the test, looking at our data, does our sample look like it's suggesting that? And I would say, yes, all but one of those data points is positive. Several of them are very positive. So I definitely have data leaning in this direction. Now the question is it statistically significant? And that's where the test comes in. So test statistic, p-value, make a decision. We should perform our checks. Checks are important so that I know those values are valid. First check is random. So anywhere in that question, did they mention random sampling or random assignment? And I see nodding. Was it random sampling or random assignment? Yeah. Yeah, right here. The order in which subjects took caffeine and placebo was randomized. That's random assignment. They didn't tell me where those 11 subjects came from, just that the order of placebo and treatment is random. So this is random assignment. If I am doing an experiment and it is random assignment, do I need to check the 10% condition? No. 10% only happens when I do sampling. I'm not sampling. This is an experiment. That's a whole different thing. So we can skip the second one. Third one, what am I checking for? Normal. And there's a list of 3 things I check for normal for a mean. First, is my sample bigger than or equal to 30? No. In the word problem, am I told the population is normal? No. How do I check if both of those things are no? Graph the sample. Yeah, graph the sample. So I'm going to scoochie over here, and we're going to graph our sample. Smallest value is what? -1. Biggest value is +19. I'm going to go -2 to 20 because it's easy to count by twos. 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I need somebody to give me the data points one by one, those differences. Do I have a volunteer? Thank you, Bailey. What was the first data point? 11. Next one? 18. 1, 4, 6. Thank you, Bailey. Weird looking data. Outliers. No. Nothing too extreme. It's all kind of spread out, but there isn't like huge, ginormous gaps. Is it lopsided? Yes. Is it seriously heavy-duty lopsided? Not really. So I would say no, I know how to spell, outliers, no strong skew. Happy face. So we pass the checks. We can now do the formula. I'll scoot you back over a little bit. So I know my t-test statistic, sample value minus population value divided by standard deviation over square root of n. And I don't have X bar and SD or SXD yet because I need to put my data in a list and run t-test in order to get it. So I'm going to give you about 90 seconds, 2 minutes, get the data in a list, run t-test. So 0 out of 3 people brought their calculator today. Tears. If it's dead, pack your charger in your backpack. Charge it during class. Yes, 4 calculators. Go up to the list header, all the way up to L2, and then press clear, enter. 4 out of 4, good job. 2 out of 3, we'll take it. 2 out of 3 using your cell phone, good. 2 out of 3 using a computer, good. 2 out of 3, Bailey, where's your calculator? Frequency is 1. Frequency is 1. What's up? Yep. Good. So I'm seeing other people getting what I got, which is this. Give you just another 30 seconds. You should be getting what's on the board for your test statistic and p-value. Technically, I need to write that over here. Is it 530? 530. 7.4 over 6.9. Oh, so that mu naught, that's the value in your null hypothesis. What's the number in our null?
Oh, 0.
Yep. Okay, and then go down to calculate because everything else looks like it's correct. And then enter. There you go. Perfect. Are you going to be taking more math classes and science classes?
I don't think so. I want to go to biology.
Oh, then yes, you will need a calculator in college.
So this is a good idea.
Yes. Yes, if you can get it cheap, get it cheap. Yeah. Yeah, if you're going into bio, you're going into med, you're going to have to take math and science, you will need a calculator. Yes.
$70 to do more math?
A lot less than you would if you were chem or physics, but yes, you will do math. There.
I should just do AP communications.
Girl. If you can survive this class, you can survive anything that bio's going to throw at you. I promise. You'll be fine. All right. If I get your attention back up front, we have our p-value. We use our sentence. If the p-value is low, we reject HO. What do we do here? Reject. Very good. This is less than alpha. We reject the null, therefore we do have evidence of the alternative. So this set of sample data does provide convincing evidence that caffeine withdrawal increases depression scores. And as a caffeine addict, I can testify to that. Which is why you're not going to see me go on a caffeine break while I'm teaching, because I don't want to inflict that depression on you. If I'm going to divest myself of it, I'll do it over summer when you don't have to see me. Famous last words. All right. Questions before we do the last one? Don't think so. We'll find out. We're going to do another one. All right. Last example says speed stacking plastic cups requires learning a routine for stacking unfilled cups in a predetermined pattern. Could using different types of cups help someone stack them faster? Some Alabama students suspected that the plastic cups from Jason's Deli, a local restaurant, would stack faster than the plastic cups from Panera Bread, a national chain restaurant. After learning a cup stacking routine, 40 statistics students timed their routine using each type of cup. Which type of cup, Jason's Deli or Panera's Bread, was used first was decided at random for each student. The difference, Jason's Deli minus Panera Bread, in time to stack the cups had a mean of negative 0.463 seconds and a standard deviation of 1.844 seconds. Do these data provide convincing evidence that Jason's Deli cups stack faster than Panera Bread cups on average? for students like the ones in this study. For this example, use the entire state plan do conclude process. So first question, what are they asking us to do? A significance test, because we check that last sentence and we see that famous phrase, does it provide convincing evidence? Very good. It says the phrase on average, so I know I'm doing a claim about a mean. Earlier in the problem, I see Jason's Deli minus Panera Bread, so I suspect this is a mean difference. So we know if I'm testing a mean difference, Z or T? T, always T. Mean difference is T. So T test for a mean difference. I'm going to define what that mean difference is. So this is the population mean difference in stacking time. And then I'm going to write the actual subtraction. I am doing Jason's Deli minus Panera. Population mean difference in stacking time. Jason's Deli minus Panera. As part of this state step, I should pick through that problem, label any numbers I'm given, write down any assumptions that I'm making. So as I pick through that problem, the first thing I encounter is 40 statistics students. So that is my what? Sample size, very good, sample size. N equals 40 Alabama students. I like the accent, that was nice. As somebody who has only ever lived in California, I cannot do a convincing Southern accent, I'm sorry. If we keep picking through that problem, we see the difference in time to stack the cups had a mean of negative 0.462 seconds. What did they just give me? Sample or population? Sample, because it came after the description of what our sample looked like. Yeah, so that is a sample mean. And what is the symbol for sample mean? X bar, very good, Will. X bar equals negative 0.462 seconds. I keep reading. Standard deviation of 1.844 seconds. It was tied to my sample mean, so that must be a sample standard deviation. And that is the last number in the problem. I am missing a number. What's missing? Alpha. I was not given a significance level. So sig level alpha equals, I'm going to go with the default 0.05. I also need to remember to state my hypotheses here. What claims am I comparing? I know this is a claim about a mean difference, so mu d, mu d. I am not given a population mean difference. So the assumption is that the Panera cups and the Jason's Deli cups don't have a difference. 0, very good, which means 0 down here, and then I need to figure out the symbol between them. So, last sentence. Do these data provide convincing evidence that Jason's Deli cups stack faster than Panera? If I am doing Jason minus Panera and Jason is faster, will that subtraction be positive or negative? Negative, because faster means smaller time. First number is smaller, less than 0. Reminders that missing that drops it from an E to a P for just that part of the problem. As long as the rest of the problem matches that, you can get E's on the rest of it. So consistency, yeah? Consistency is important. Good. That is the end of the state. What comes next? The plan. We do the checks. First check. Random sampling or random assignment. Which did we do here? Random assignment of cup order, yeah. So random assignment of cup order, yeah. Some of them use the Jason's Deli first and the Panera second. Some use Panera first, Jason's Deli second. Bless you. Because it was random assignment, do I need to check 10%? No, I can skip right to normal, and I go down my checklist. First check for normal is sample size. Is it bigger than or equal to 30? Yes. Our sample size was 40 students, which is bigger than or equal to 30. Therefore, our sampling distribution will be normal. Happy face. That's it. That was it. That's the whole plan stage. If you don't have to check your sample shape, it goes fast. That's why we like means. Next step, Marilyn, I got to calculate 2 things. What am I calculating? Same as the last question. What 2 things am I calculating? P-value and? The test statistic. Yeah, the t-test statistic. Good. The test statistic gets a formula. The p-value gets a picture. I know the formula for test statistics. Sample minus population divided by standard error. Again, you don't have to have those memorized. You do know how to need to know how to figure it out from the equation sheet. This is posted in Google Classroom. You can do a Google search for it, AP Stats formula sheet. Use these with your homework. It'll help. Yeah? We have those values this time. So what was our sample mean? Negative 0.467? What was it? 462. 462. I just knew there was one somewhere in today's notes. I couldn't remember where. Standard deviation 844 divided by square root of sample size of 40. And then we run t-tests. T-test. I'm getting thumbs up and nodding, so that's a good sign. I'm going to draw my picture next to that to interpret that in terms of my sampling distribution. So quick t distribution. Sample statistics of -1.5. So 0.0606 is sitting there. So we expect about 6% of all samples of size 40 from the population to end up with a mean difference time of -0.462 or less. Okay, I have one more step, which is my conclude. Before I do my conclude, I'm going to look at my decision. Thank you for sharing that with the class. And we use the phrase, if the p-value is low, we reject HO. Is my p-value less than my alpha? No, this is greater than 0.05. So my conclusion, because the p-value of 0.0606 is greater than alpha equals 0.05, we fail to reject the null. That is the first of two sentences. I have addressed the null. Now I need to address the alternative. If I do not reject the null, do I have evidence for the alternative? No, it's a no and a no, or a yes and a yes. If it was a no on rejecting, it's a no on evidence. So there is not convincing evidence of our alternative. And I'm going to pull the context for my alternative from wording from the question. So if I go back and I look, it says, do the data provide convincing evidence that Jason's Deli cups stack faster than Panera cups on average? So there is not convincing evidence that Jason's Deli cups stack faster than Panera on average. Please remember both sentences. If you address one and not the other, that's automatically E to a P, right? And we know that starts to hit really hard because we know how they calculate, and often to get a 4, you need all E's. Second, you get a P, that's down to 3, maybe even a 2. So you've got to really be careful with those details. For most of those questions, unless it's a really big, like the exploratory task, there's usually a little bit more leeway. But for the shorter questions, it's usually all E's is a 4. Remember, your goal on average is 50% across the board. And somebody said they took a look at the scoring calculator, and this year 50 across the board is now a 4 instead of a 3. And I see some nodding. Yes, Will? If you took the test today, if I took the test today, could I get a 5? Probably. I would say the only reason I might not get a 5 is I have ADHD, and so I struggle with time. And if I didn't get a time accommodation, I might struggle to finish. But the part that I did finish, I am confident I would get a 5. But again, I have been doing statistics for longer than you've been alive and teaching it for almost as long as you've been alive. So it's not really a fair comparison, right? All right. Reminders, homework 7A is due today. If you have questions, I'm available after school. You can send me emails. If you haven't filled out this survey in Google Classroom, do it today. It closes tonight. I'm going to publish our Saturday session scheduling tomorrow.